You might find that making a disposable prototype enclosure helps you visualize your project and iterate on your user interface without a lot of investment or waste. Then you can head into the process of making a more sophisticated enclosure with a more certain idea of what will work. For a more polished and less DIY appearance, consider ready-made electronics project enclosures. These can provide a cleaner and more professional look and often already have mounting spots for your circuit board. But your search shouldn't stop at boxes designed just for electronics. You can also get clear plastic boxes designed for memorabilia display, like for hockey pucks and baseballs. I'm particularly fond of using shadow boxes as electronics enclosures because they offer a nice-looking display while being easy to add your components. You can use the glass along with some printer paper to diffuse some LEDs, or leave it out to provide access to touch buttons and knobs. When drilling into plastic, I recommend using a step drill to avoid cracking it. These cone-shaped drill bits also work well on metal project boxes. Laser cutting is a popular option for making enclosures, often from thin plywood, sheet acrylic, or even cardboard. There are a handful of laserable box generators online that make it easy to create an appropriately sized box based on your project dimensions. For a totally bespoke enclosure, 3D printing your own box is an excellent option. First, use calipers to measure your project's dimensions. You need accurate information to create the perfect fit. Record the length, width, and height of your circuit board, as well as the clearance needed and positioning for any components that need to protrude to the outside of the enclosure. Make a sketch of your object and use it to record the relevant dimensions. Even if it's just a rough diagram, it will help you find or design a project box that will fit. Next, use a free 3D modeling program like Tinkercad or Fusion 360 to design your enclosure. Make sure to include necessary mounting points and openings for your switches, connectors, and LEDs. Be sure to include a little extra space called tolerance, since in real life, the parts need to sit next to each other and can't overlap. You'll find some exquisite examples of custom enclosure design online. Sometimes they have space for specific fastening hardware like nuts and bolts or heat set inserts. 3D design is a big topic, too big for me to do justice in a short tutorial video like this one, so I've put some links to resources for learning more in the write-up that goes with this video. But my basic strategy is to make a hollow box with holes in the right places. Once you have your enclosure in 3D, you can print it out yourself or send off the file to be printed for you. The digital design will become a physical copy. Then you can put your components inside and determine if any revisions are needed. It's normal to make several iterations and make some improvements along the way.